So looking at this final example, in the subtopic of forces and acceleration, we have an exam style question. It says, a ball is thrown 20 meters per second vertically upwards, taking G, gravitational force, as 10 meters per second squared, and ground as origin of displacement. The force has given us acceleration, which is -10. A. Show v squared equals to 400 minus 20x and find the greatest height that the ball reaches. And then B. Find x in terms of t, what we're looking for, and how long it takes the ball to reach greatest height. Start with A over here. V squared equals to 400 minus 20x. And we've been given acceleration. We have x double dot equals to -10, correct? Coming back to this, we're trying to find v squared. So we're going to use this format of the substitution for the acceleration, which will be d dx half v squared equals to -10. Correct? Integrate both sides, we get half v squared equals to -10x plus c, plus c1, times 2 from both sides. We get v squared equals to -20x plus c1. When we multiply 2 by a constant, it still remains a constant, so we'll just leave it as c1. Now, to find c1, correct, is thrown at 20 meters per second initially. So when it's been thrown initially, it's going to be at 20 meters per second. So when x equals to 0, v squared is going to be 20 meters per second. V is going to be 20 meters per second, so that's going to be 400 equals to -20 times 0 is 0 plus c1. So c1 is 400. Therefore, v squared then gives me 400 minus 20x, which is this over here. Next part, find greatest height. When we talk about these sort of questions, the greatest height is when velocity is going to be 0, the turning point, right, at a graph. So if we're talking about a graph over here, let's just say this is the graph. The greatest point is always going to be this. The turning point is when the velocity is always 0. So in this case, v is going to be 0. 400 minus 20x. So x then equals to 20 meters. So the greatest height this ball reaches is 20 meters. That is how we do A. Let's get on to B now. Coming on to B now, find x in terms of t. So let's go back to this over here. We have v squared equals to 400 minus 20x. Take the square root, so v equals to the square root of 400 minus 20x. The only reason we're taking the positive case is because when the ball is rising upwards, it's going in a positive direction. So that's why we don't take the negative case, because it's not falling down, it's going upwards at the start. So that is the velocity function we have over here. How can we write velocity in terms of x and t? We can go dx upon dt equals to 1 upon, sorry, not 1 upon that, it's going to be, my bad, 400 minus 20x. Now we take the reciprocate this, we get dt upon dx, which is then it's going to be 1 upon 400 minus 20x, correct? Integrate, so multiply both sides by dx, so we're left with dt equals to dx upon square root of 400 minus 20x. integrate both sides. To do the integral for this, we'll use integration by substitution. Let u equal to this 400 minus 20x. You should cover integration by substitution in both extension 1 and in 4-unit maths. Take the first derivative, du upon dx equals to negative 20. Du upon negative 20 equals to dx in this case. So let's sub in dx for this and u over here. Just going to draw a quick line over here. Next step, we'll come back to this over here. Yeah, so we'll do it over here. We have t equals to integral of 1 upon negative 20, because we're multiplying the dx over here, du all upon square root of u. U to the power of, so t then equals to negative 1 upon 20, integral of u to the power of negative 1 upon 2 du, so t then equals to, add 1 to the power, multiply over here, so we then get 2 upon negative 20, 2 upon negative 20, we get root u plus c2. Correct? This is what we get. Let's come back to, actually no, we can just do it at the bottom over here. Next step would be t equals to negative 1 upon 10. We get square root of 400 minus 20x over here plus c2. Now we'll come back over here. When t equals to 0, as it says, as ground displacement, v will also be, x will also be 0. So when t equals 0, x is also 0. So we have t then equals to negative 1 upon 10 square root of 400 plus c, which then gives me negative 2 plus c2, So this is 0. This is also going to be 0, my bad. So c of 2 then equals to 2. Correct? Sub this back into this, this equation over here. So t then equals to negative 1 upon 10 square root of 400 minus 20x plus 2. That is t in terms of x. We can rewrite this in terms of x in terms of t, So minus 2 from both sides and multiply that by 10. So we then get 10t, negative 10t plus 20 equals to square root of 400 minus 20x. Correct? Square both sides. We get 20 minus 10t all squared equals to 400 minus 20x. Correct? Next step, add 20x, bring this on the other side. 20x equals to 400 minus to 20 minus 10t all squared. Correct? Final step, divide both sides by 20. So x then equals to 400 minus 20 minus 10t all squared all upon 20. So that is x in terms of t we've been given over here. Next part is how long it takes the ball to reach the greatest height. time taken to reach greatest height, correct? So when x equals to 20, that's when v equals to 0, correct? So we'll sub this back into this over here. Yeah, we'll sub it back into, so we're going to sub it back into this equation that right here. So let's come over here. So t, right over here, so t equals to 2 minus 1 upon 10 square root of 400 minus 20x, correct? Since that's the case, the velocity is going to be 0 for the ball at x equals 20, so that's the turning point, that's the max height it reaches. Time taken to reach the max height, sub in 20 over here, so this then gives me t equals to 2 minus 400 minus 400 is 0, 0 multiplied by 1 upon 10 is still 0, so t is 2 seconds. Interesting sort of question, but yeah, that is how you do this over here.